Hi, I'm going to run through 3 different problems with you. These problems were identified by students yesterday, and they were seeking additional help understanding problems similar to this. So in the expression you're looking at, we're being asked to simplify this. So we're going to rewrite and simplify. Now, notice that we don't see an nth root. So what is the nth root? It is 2. And also notice that 12, 27, and 300 in this column don't exist. So let's first focus on the smallest of those numbers, which happens to be 12. And I can see that although 12 does not exist, 12 would lie between 9 and 16. So I'm going to work myself backwards and think, are there 2 numbers, one which would have to be in this column with the 2, because there's a hidden nth root of 2. Are there 2 numbers, one which would have to be in this column, that multiplied to equal 12? So like, is 9 times the nice whole number 12? No. Is 4 times the nice whole number 12? Yeah. 4 times 3 is 12. One of the numbers has to be in this column. Why is it this column? Because it's the nth root of 2. So I'm going to rewrite this as 4 times 3. And also note that I started with the smallest, not because this is the first term of the 3 terms in this expression. It's the smallest one inside of this radical house. Now I know that the square root of 4 is 2. So this is 10 times 2 times the square root of 3. So this is 20 square roots of 3. And that 3 is going to be a key indicator to go, oh, okay, is there a number that I can take times the square root of 3 and get 27? 9 times 3, and see how important that is, because 9 lies in this column. I know the square root of 9 is 3, and there's a 5 out front. 5 times 3 is 15, so I have to subtract 15 and the square root of 3. Over here, again, let's put the 3. 3 times what is 300? 100. And again, 100 is in this column with the 2. Why are we choosing this column? Because the nth root is 2. So the square root of 100 is 10. 2 times 10 is 20, so I have plus 20 square root of 3. Now the next step is not like a traditional math step. I've just chosen to say star equals the square root of 3. So 20 star, it's not necessary unless this helps you. Subtract 15 star plus 20 star. 20 subtract 15 is 5. 5 and 20 is 25. And remember, it's not 25 star. Star really is square root of 3. Okay, let's go on to example. Remember that to understand this problem, I want you to think of it in 2 ways. This is an expression, and this is an expression. And we want to know, when do these 2 expressions equal each other? When are the x values exactly the same, so the left side equals the right side? So let's figure this out mathematically first. So to get rid of a square root, I'm going to square both sides. Whatever I do to one side, I have to do to the opposite side. And they cancel out because they're opposite operations, and I have 7x plus 5 equals 9x plus 3. Now we're going to move the x's to the side of your preference. 5 equals 2x plus 3, and 2 equals 2x divided by 2, and x equals 1. Now, is that correct? Is this correct? Well, there's 2 ways to check. The first way to check is to check algebraically to see, is this an extraneous solution? So I come up here and I plug it in. 7 times 1. Why is it 1? That's the answer I achieved algebraically. 7 times 1 is 7. 7 plus 5 is 12. So on the left side, I have the square root of 12. On the right side, substituting 1 in for x, 9 times 1 is 9, plus 3 is 12. I just proved the left side equals the right side, which means this is an answer. Is there another way that we can do it? And I'm going to flip from this screen now to Desmos. So if you go into Desmos, and we are going to think of this as now 2 equations. That's one equation, and that's the second equation. One equation, and that's the second equation. And I want to see, where do they intersect on the graph? So y equals the square root of 7x plus 5. The next, y equals the square root of 9x plus 3. And I can see they cross at one place. So if I click on that place, you may be thinking, well, which number matters? Is it the first number or the second number? When we go back to our equation, I'm only solving for x. So when I look at this point, the ordered pair, the only one I care about is the x. On a graph, it will eliminate extraneous solutions and only show you the real answer. The real answer will occur where they intersect. So the real answer here is x equals 1. So I just showed you two ways, graphically or plugging it back in algebraically to prove that this is the correct answer. Another problem looks very similar to our last one. Well, let's solve it first algebraically. So I square both sides. Two operations cancel out. I have 7x plus 5. I'm going to go about quickly here. You move the x's to the side of your preference. 8 subtract 1 is 6. Move the 5 over. Divide by 2. X equals -2. Now, just because we get an answer that's negative, that does not mean, a negative answer does not automatically mean this doesn't work. Does not mean that at all. But let's check and see. So I'm going to take the -2 and I'm going to plug it in. 7 times -2 is -14. And -14 plus 5, -14 plus 5 is -9. So I have -9 over here. And I plug in the -2 here. -2 minus 7 is -9. So this looks a little odd. And some students may say, well, the left side equals the right side. They're exactly the same. And the problem before we had the same number, what's different about this is we're working with a square root. And we have previously learned that unless you take the negative sign out front and it becomes an imaginary number, unless that happens, we can't take the square root of a negative number. It's not possible, again, unless we take this out, it becomes imaginary. So right now my thought is it's not possible. It may be no solution. Well, let's check graphically. So again, think of this very clear, this original equation. There's one equation. It's one expression I'm turning into equation. Here's the second expression I'm turning into equation, and I want to know where do they cross. So here was the left-hand side. The right-hand side was x minus 7. Now let's check. Where do they cross? They never, ever, ever cross. Well, if the point at which they cross represents the solution and they never cross, that means the answer is no solution. I did all the math right. It doesn't matter that it's negative. That's not the key. Up here, I could have been able to say no solution if I realized I can't take the square root of a negative, or I could graph it and see they never cross as well.